Okay, we'll approach question 11, the either question. All right, I'll do both either and or. Then later on in the summary, I'll talk about how to select the either or question. All right, so state one difference other than their speeds between sound and light. All right, so the fact that their waves are something you should know. All right, so sound is the only longitudinal wave in your syllabus. All right, and light is clearly a transverse wave. All right, you should know that from EM waves. What's the speed of light in a vacuum? This one you should be very familiar. 3 times 10 to the power 8 meter per second. Right, define the refractive index of glass in terms of speed of light in glass and speed of light in vacuum. Right, so it's just the ratio of speed of light in a vacuum to speed of light in a glass. Right, so you're supposed to memorize. Right, so they're so nice that they give you this line. Alright, so this is a very easy question. Okay, state how a refractive index of glass shows that light travels faster in a vacuum than in glass. Right, so the easy answer is that since it's this divided by this, alright, the ratio must be greater than 1, alright, or the refractive index of all glasses are greater than 1, alright, so that shows that speed of light must be higher than, speed of light in vacuum must be higher than speed of light in glass. Right, light travels faster in air than in glass, but sound travels faster in glass than in air. Right, using ideas about molecules, explain why sound travels faster in glass than in air. Using ideas about molecules, right, is very specifically referring to kinetic model, right? So you are supposed to use kinetic model to answer this question. That means you have to think of the glass as solids vibrating and air molecules as randomly moving particles, right? So the reason why sound travels faster in glass than in air is because when sound waves transmit energy, right, they require collisions between particles, and since glass particles is in solid form, right, they're much closer to one another than air particles, which is in gaseous form, right? So it's easier for glass particles to hit each other than for air particles to hit each other, right? So this explains how the sound wave is transmitted much faster in a solid than in a air. Alright, so this is straightforward as well. Okay, I'll go for the final question. Okay, describe a direct method for measurement of speed of sound in air, making it clear how this result is calculated. You may draw a diagram if you wish. Alright, again, the you may draw a diagram if you wish basically means you should draw a diagram. Okay, so I didn't draw a diagram in this question because in this question it's not so important to draw a diagram, right? You can just draw A and B and the distance between them to be 800 to 1000 meters, right? In your textbook is 800 okay, so but some places write 1000, so it doesn't really matter, right? So just 1 mark for the distance they are apart, right? It has to be roughly this distance due to the speed of sound, so it will take about 3 seconds for the sound to travel from A to B, right? If A fires the pistol, right? The second mark goes towards the procedure, right? When A fires the pistol, observer B sees the flash, right, and starts the stopwatch. Okay, then he stops the stopwatch when he hears the sound, right, and they record the time as t. This thing is taken to be the time taken from A to B, right? Because we assume speed of light is so fast that it's instantaneous to reach B's eyes. Alright, so repeat the two experiments twice to minimize random error. Then you have the exchange positions of observer A and B to minimize the effect of wind. Right, because if the wind is in the direction of the transmission of sound, right, actually the sound wave will travel faster. Right, so when you rotate their positions, you take out that variable from the measurement. Okay, so there you have it. Okay, repeat 3 more times because you have 3 times in one direction, right? And then 3 times in the opposite direction. That means when A and B swap, we do 3 more times. Okay, find the average time taken, and of course, speed of sound calculation is this. Right, if you don't know where this experiment is in your textbook, okay, you can refer to textbook page 292, right? It's investigation 15.1. Okay, so these were very easy 4 marks if you had memorized this. And it's not difficult to memorize, right? It's quite straightforward. It is possible that you may want to say this distance is measured via using a measuring tape, right? As per what your textbook mentioned. Okay, maybe I'll just add here. Measured Fire measuring tape. Just in case,